Hello students, today we are going to talk about the properties of nerve fibers. The first property is excitability. Now here the nerve fibers, on account of presence of a polarized membrane, have the ability to perceive stimulus and to enter into a state of activity. So the nerve fibers, they have a membrane, the neuron membrane, that is called as neurolemma. Now in this membrane is polarized and it has the ability to perceive the stimulus. It has the ability to take the stimulus and to enter into a state of activity. Once the membrane gets the stimulus, it enters into a state of local excitation. That means it enters into a state of excitement or the state of activity. Now the second property, that is stimulus. Stimulus is of four types. First is physical stimulus. It consists of heat or cold. Second is chemical stimulus. It consists of acid or base. Third is mechanical stimulus. It consists or it makes an impact on the nerve fibers. For example, injury. And the next is electrical stimulus. So the stimulus are of four types. Physical stimulus, the nerve fibers may get stimulated due to heat or cold. Chemical stimulus, the nerve fibers may also get stimulated because of some acid and base. And mechanical stimulus, the nerve fibers get stimulated because of an impact which is done on the nerve fibers. For example, any injury. If you suffer from any injury, at that time what happens? The nerve fibers, they get stimulated. And the next is electrical stimulus. Now any of these things, when stimulate a nerve fiber, it comes into a state of local excitation or the state of activity. That is, only one point gets excited. So on the membrane of the neurons, what happens if any of the stimulus acts on the membrane of the neuron or the nerve fiber, membrane of the nerve fiber. So any of the stimulus, if it acts on the membrane of the nerve fiber, what happens? Only one point on the nerve fiber gets excited, and this stimulus is passed on from one point to other point on the membrane of the nerve fiber. So with the help of any of this stimulus, if the nerve fiber gets stimulated, it comes into a state of activity, and when it gets the stimulus, at that time only one point on the nervous membrane or the membrane of the nerve fiber, only one point gets excited. Now, any detectable physical, chemical, electrical change in external and internal environment that brings about excitation in a nerve fiber or in the muscle or in the organ or an organism, the stimulus must have minimum intensity, called as threshold stimulus. Now, as I said, the nerve fiber gets stimulated by any of these membrane. It is detectable. We can detect that stimulus in a physical state, chemical state, electrical state. If the change occurs in external environment or internal environment, at that time the nervous membrane or the nerve fiber, they get stimulated, or even a muscle, that it gets stimulated, or organ, it gets stimulated, or organism. So the stimulus must have minimum intensity, called as threshold stimulus. Now the stimulus should have minimum intensity. The stimulus should be of minimum intensity, that is from -55 to -60 microvolts. Now subliminal stimulus, that is weak stimulus. If the intensity of the stimulus is weak, so there will be no effect on the nerve fiber. The nerve fiber will not get stimulated if the stimulus is weak. On the other hand, if the stimulus is strong, still what happens? The same degree of impulse as the threshold, the intensity is the intensity of stimulated nerve fiber, or intensity in which the nerve fiber gets stimulated, is same as the impulse of the threshold, that is from -55 to -60 microvolts. So when the stimulus is weak, there is no effect on the nerve fiber. The nerve fiber will not get stimulated. And when the stimulation is strong, that is supraliminal stimulus, at that time, even if the stimulus is very strong, still the nerve fiber will get stimulated at the intensity of the same degree as the threshold stimulus. So if the signal is weak, or if the stimulus is weak, the nerve fiber will not get excited. And even if the stimulus is strong, the nerve fiber will get excited or will get stimulated at the intensity or at the same degree as the threshold impulse is there, or threshold stimulus is there. The next property that we are going to see is the differential permeability. Now here what happens, the neurolemma or the membrane of the neurons or the nerve fibers, that is neurolemma, it shows differential permeability. That is, it allows the certain ions to pass through it. That is called as permeability. Now this permeability is different for different ions. So that's why it is called as differential permeability. Now here this neurolemma, inside the axon there is neuroplasm, or the fluid which is present inside, it is called as neuroplasm. Whereas the fluid which is present outside the axon or outside the membrane, that is called as extracellular fluid. Now in this extracellular fluid there are sodium ions present. Sodium ions are present in the neuroplasm also. But the difference is the sodium ions which are present in the extracellular fluid are, or the concentration of sodium ions which is present in the extracellular fluid is 10 times more than the concentration of sodium ions which are in the neuroplasm. Whereas in the neuroplasm, potassium ions are present. The concentration of potassium ions inside the neuroplasm is 30 to 40 times more as compared to the concentration of potassium ions inside the extracellular fluid. So sodium and potassium ions are present in both the sides, outside the membrane and inside the membrane, in the extracellular fluid also and in the neuroplasm also. But the only difference is the potassium ions which are present inside the neuroplasm are the concentration of the potassium ions which is present inside the neuroplasm is 30 to 40 times more as compared to the concentration of potassium ions which is present inside the extracellular fluid. Whereas the concentration of sodium ions which is present inside the extracellular fluid is 10 times more as compared to the concentration of sodium ions which is present inside the neuroplasm. So here in the neuroplasm, the concentration of potassium ion is more as compared to the extracellular fluid. And here in the extracellular fluid, the concentration of sodium ion is more as compared to the neuroplasm. This neuroplasm also consists of organic molecules. These organic molecules are negatively charged proteins. The neuroplasm also consists of organic molecules, and these organic molecules are negatively charged proteins. Due to this negatively charged proteins, the inner side of the membrane, inner side of the neurolemma gets its negative charge. Whereas due to the concentration of sodium ions, the outer side of the membrane or the outer side of the neurolemma is positively charged. So because of these negatively charged proteins, the inner side of neurolemma is electronegative, whereas due to the presence of this more concentration of sodium ions, the outer side of the neurolemma is electropositive. Now this neurolemma, it also has channel proteins. It has channel proteins which act as channel gates. It allows certain ions, certain channel allows certain ions to pass through the neurolemma, to pass through the membrane. So these channels are sodium channel. It allows the sodium ion to pass through the membrane of the nerve fiber or neurolemma. It also has potassium channel, it has calcium channel and chloride channel. So these channel allow the certain ions to pass through this neurolemma. When the stimulus is given to the neurolemma, when it gets stimulated, at that time certain ion channels or certain channel gates or ion gates or protein channel gates, they allow the certain ions to pass through this neurolemma. At the resting state, the membrane is more permeable to potassium ions when there is no stimulus provided to this neurolemma. So at that time, that is the resting state, at that time this membrane neurolemma is more permeable to potassium ions. Next property, that is conductivity. Conductivity is the ability to transmit the excitation or the stimulus, or here we will use a new word, that is impulse. So conductivity is the ability to transmit the impulse from one point to another point on the membrane. Now here, suppose this is the membrane of nerve fiber, that is neurolemma. This is the membrane, neurolemma. Now here, when this membrane receives the stimulus, at the point where it receives the stimulus, at the point where the stimulus is received by the membrane, here what happens? The sodium ion, they move in the membrane. And as the sodium ions, they move in, what happens? In the inner side of the membrane, positively charged particles will increase, or the inner side will become more positively charged as the sodium ions, they move inside the membrane. So it will look like this. As the sodium ions move inside the membrane, the positively charged particles here increase, and or this inner membrane becomes electropositive. So it will look like this. The positively charged particles here will increase. So the inner membrane will become electropositive and the outer membrane will become electronegative. So here, this is the place where we say that the impulse has been generated. When the ions, sodium ions, they pass through the neurolemma, they pass through the membrane. So here they permeate through the membrane from outer side to the inner side. At that time, charges are exchanged. So here the inner side of the membrane becomes positively charged and the outer side becomes negatively charged, or the inner side becomes electropositive and the outer side becomes electronegative. Here it is said that the impulse has been generated. Now, as the impulse is generated, this impulse has to travel from one point to another point. So, this impulse has to travel from one point to another point. So, this positive charge will come here and this negative charge will move this side. This positive charge will move here. This negative charge will move this side. So, here it is seen in this way. The positive charge comes to this side and negative charge moves this side, whereas the negative charge on the outer membrane moves that side, is transferred to that side, and positive charge is also transferred to that side. So here, suppose if we name these points as point number 1, number 2, number 3, number 4 and number 5. So it when the impulse is generated, at that time this impulse has to be transmitted or transported or transferred from one point to another point. So here, this impulse which was generated here on the second point, it has been transmitted or transported to the third point. So from third point it will be transferred to the fourth point. From fourth point it will be transported to the fifth point. So this ability or this property of the impulse from moving or getting transferred from one point to another point, that property is called as conductivity. That ability of impulse to transfer or to transmit the impulse from one point to another point, that property is called as conductivity. The next property that we will talk about is the refractory period. Refractory period is the time interval during which a nerve fails to respond the second stimulus, or it can be said as the resting period of the membrane. Now what happened, as we saw here, the stimulus was given to a certain point on the membrane, and when the stimulus was given here, this membrane's permeability changed. Permeability changed means what happened? This membrane, it allowed sodium ion to come inside. The permeability of the membrane changed means the sodium ion came inside. So as this sodium ion came inside, what happened? Here inside the membrane, it became positively charged, or the positively charged particles increased inside the membrane, in the inner side of the membrane, whereas in the outer side of the membrane the negatively charged particles increased. So when the sodium ion came in, this inner side of the membrane became electropositive, whereas the outer side of the membrane became electronegative. Here this was the place where we said that the impulse was generated. Impulse is generated, or impulse was generated here at the place. Now this impulse had to travel from one point to another point. So we said that the impulse traveled from point 2 to point 3. Here also this negative charge traveled from point 2 to point 3. Here the positive charge traveled from point 2 to point 3. So what happened here, as this charges, they traveled, or they get transported from one point to another point. What happened here? The positive charged or positive charged particle or ion, it gets transported over here, and here the negative charged ion got transported. But now what happened here? In the normal case, the positive charge was because of sodium ion. It was because of sodium ion. When that sodium ion came inside due to the change in permeability of the membrane, the sodium ion, when it came inside, at the same time, what happened? Potassium ion, which was present inside the membrane, it was given out. So here charge wise it is right. Positive charge outside and negative charge inside. But here the positive charge is because of potassium ion. Because the potassium ion which was given out, the positive charge is due to the potassium ion. And here this positive charge is because of the sodium ion. So what has happened over here? In normal case, when the stimulus was given to the membrane, or when the stimulus was provided on a point of the membrane, what happened? The membrane's permeability for the sodium ion changed. The permeability changed and the sodium ion was taken in, or the sodium ion moved in, and potassium ion moved out. So here the impulse was generated. As the sodium ion moved in, the impulse was generated. This impulse traveled from one point to other point. Now here at this point, if any other stimulus is provided, what will happen? There is no there is no sodium ion outside over here. Whatever sodium ion was there, it was taken in already. So here positive charge is there, but that positive charge is of potassium ion. There is no sodium ion outside. So even if the stimulus is provided here at this point, at the same point, point 2, even if the stimulus is provided over here, what will happen? The permeability of the membrane will change. For whom? For sodium ions. But as there are no sodium ions over here, they will not move in. The impulse will not be generated, or the nerve fiber will not get excited. As the impulse is not generated, the nerve will not get excited. So even if the stimulus is provided, even if that stimulus is of threshold intensity, Even if the stimulus is provided, there will be no generation of impulse. Why? Because there is no sodium ion present here outside the membrane, outer side of the membrane. Only sodium ions, the impulse is generated only when the sodium ions are present in the extracellular fluid, and those sodium ions, they move inside the neuroplasm because of the change in the permeability of the membrane. Only when the impulse is generated and the nerve gets excited. But here there are no sodium ions, so sodium ions will not enter inside the membrane. That's why the impulse will not be generated and the nerve will not get excited. So this state is called the refractory period. Refractory period is when the membrane is or the nerve fails to respond to the second stimulus. The second stimulus is given, the nerve fails to respond to the second stimulus. That period is called as the refractory period, or it is also called as the resting period. Now this refractory period can be divided into two types. First is absolute refractive period and second is relative refractory period. Now here in the absolute refractory period, what happens? The same thing happens over here. No excitation even when the threshold stimulus is given, because here sodium ions are absent, only potassium ions are present. So even if at the same point the second stimulus is given, the nerve will not get excited because the impulse will not be generated over here, because sodium ions are not present over here. Now the second type is the relative refractory period. Now here what happens in the relative refractory period? The nerve can get excited when more than threshold value is provided. Now here what happens after some time, after few seconds, few milliseconds you can say, the sodium ions which are present here inside in the inner side of the membrane, these sodium ions, they move out due to the sodium and potassium pump. So these sodium ions, they move out at that time when the threshold or when more than the threshold intensity or more than the threshold value stimulus is given. At that time this sodium ions, they can again come in because of the change in permeability of the membrane. They can come in and again the impulse can be generated over here. So the nerve can get excited. So here in relative refractory period, the nerve can get excited only when the threshold value stimulus, more than threshold value stimulus is provided. Only when more than threshold value stimulus is provided and only when sodium ions are present in the outer side of the membrane. These sodium ions, when they enter in the inner side after the impulse is generated, when they enter in the inner side, at that time after few milliseconds, what happens? They start moving outside. They start moving outside of the membrane due to the sodium and potassium pump. So when few sodium ions which are present outside the membrane of the nerve fiber, at that time when more than threshold value stimulus is provided, the nerve can get excited and the impulse can be generated. So this is the refractory period. The sixth property. The sixth property of the nerve fibers is summation. The sixth property of the nerve fibers is summation. Now the nerve fibers will get excited only when the threshold stimulus intensity, we said that the nerve fibers will get excited only when we provide the stimulus of threshold value. But even if the low intensity stimulus or the stimulus lower than threshold value is provided continuously for continuous period of time, at that time also the nerve can get excited. So when we say if the stimulus less than threshold value is provided, continuously to the nerve, the impulse can be generated. Impulse can be generated. And nerve can be excited due to the summed up effect. It happens because of the summed up effect, due to the summed up effect, due to the summed up effect. This property is called as summation. So here, if the stimulus which is less than threshold value, if it is provided continuously, one after the other, it is provided continuously to the nerve, the impulse can be generated. Even the stimulus is below the threshold value. So, if it is provided continuously, the nerve can be excited or the impulse can be generated. And this happens because of the summed up effect. That is why this property is called as the summation. So, these are the properties of the nerve fibers which